Based on analysis of available data and technical reporting from late 2025, the vessel known as the Type 076 amphibious assault ship, with the name Sichuan associated with it, has entered a new and critical stage of its development. The central development is the commencement of testing for its integrated electromagnetic aircraft launch system, a feature that places this class of vessel in a unique category globally. This system's activation marks a pivotal shift in the operational potential of amphibious warfare ships, moving their role beyond that of a platform solely for helicopters and vertical lift aircraft to one capable of operating a wider range of high-performance fixed-wing aircraft, particularly unmanned systems. The initial test phase, which occurred in the latter part of October 2025, involved a fundamental procedure known as a dead load or sled test. This is a standard but essential engineering validation step where a heavy, wheeled sled, designed to replicate the mass and landing gear characteristics of an actual aircraft, is engaged with the Catapult shuttle. The electromagnetic launch system then activates, accelerating the sled at high velocity down the length of the launch track on the deck before it is projected off the ship's bow and into the water. The primary purpose of this test is not to launch a functional aircraft, but to gather immense amounts of data on the physical and electrical performance of the entire system. Engineers analyze the acceleration curve, the force application consistency, the stability of the power delivery from the pulsed energy storage systems, the structural stresses on the deck and sled, and the overall integration of the complex machinery. A successful sled test is a non-negotiable prerequisite that de-risks the program before proceeding to the far more sensitive and valuable stage of launching actual aircraft prototypes. The core technology being tested, the electromagnetic aircraft launch system, operates on principles distinct from previous steam catapults. It functions as a linear motor, using powerful electromagnetic fields to propel the launch shuttle along a track. This method offers a significant degree of precision control over the launch profile. The amount of force and the acceleration curve can be finely tuned via computer control to match the exact weight, balance, and required takeoff speed of different aircraft. This flexibility is especially advantageous for launching unmanned combat air vehicles, which can have varied designs and weights, and for ensuring reduced wear and tear on both the launch system and the airframes compared to the more violent and less adjustable impulse of a steam catapult. The vessel designed to accommodate this system is substantial, with an estimated full load displacement ranging between 40,000 and 50,000 tons. Its architecture is defined by a full-length flight deck that is configured to support concurrent launch and recovery cycles. The forward section of the deck is built around the one or more electromagnetic catapult tracks. The aft section of the flight deck is equipped with arresting gear, which is a system of steel cables and hydraulic or electromagnetic energy absorbers. This apparatus is designed to catch a tailhook deployed by a landing aircraft, rapidly decelerating it to a safe stop within the very short deck space available. This combination of catapult and arresting gear is what defines a vessel capable of conventional takeoff and landing operations for fixed-wing aircraft. Despite this advanced aviation capability, the ship retains its fundamental amphibious nature through an internal well deck located at the stern. This flooded dock allows the vessel to launch and recover landing craft, which are used to transport vehicles, equipment, and marines from the ship to shore. The intended operational doctrine for the Type 076 appears to be that of a dedicated aviation platform for unmanned systems, effectively functioning as an unmanned aircraft carrier with a secondary amphibious assault capacity. Its primary air wing is expected to consist of large, fixed-wing unmanned combat air vehicles. These unmanned systems would be tasked with providing a persistent and survivable platform for intelligence, surveillance, and reconnaissance missions, as well as for precision strike operations. By embedding this capability directly within an amphibious-ready group, the vessel provides commanders with organic, long-range situational awareness and standoff firepower that can shape the battlespace ahead of and during an amphibious landing. The ship's reported capacity to embark over 1,000 Marines, along with their equipment and landing craft, means it can directly support the entire sequence of an assault, from initial reconnaissance and suppression of enemy defenses by its unmanned aircraft to the actual landing of forces on a hostile shoreline. The development of this ship class signifies a strategic move towards more distributed, networked naval operations where aviation capabilities are dispersed across a larger number of platforms, thereby increasing the overall resilience and tactical flexibility of a fleet.